Let's turn off the visibility of the doors so we could take a look at these hinges again and all the hardware that we put into the system. So when we first placed it, we located it, but we did not actually drill any of the negative shapes as of yet. They're there, sitting there waiting for us. Those were the items that were in blue that I had indicated earlier. So we've got cam connectors, we've got shelf pins, we got all the pilot holes. So again, we can do this more in a manual mode in Inventor, but developing certain tools that allow me to do what I call automatic drilling. I can just hit the yes button and it'll prompt me to, do I want everything to be drilled at one time, or I can selectively drill what I want. And again, without going back and forth into parts, into assemblies, projecting, all the things that we have to do today, this is taking care of it in one step. That's why we can think of the joinery and the hardware after the fact rather than as we're building. Because as we're building, sometimes we're not sure where things should go. We're doing just conceptual modeling. We're trying different things, addressing different issues. Clients are asking us to change on the fly, and if we put lots and lots of time into the model, backing out of it sometimes does take a bit of energy. So this is going to minimize as much of this, and we've seen people start using tools like this and save a day a week per designer. Also, it's going to give us accuracy, easier accuracy, or easy to attain accuracy. I'll turn off the hardware so that you can see that all the holes, all the negative shapes were drilled. It's a one-time affair. We can do it up front, we can do it as we're putting the hardware in, or we can do this after the fact. So again, up to the individual user to determine when they would like to do it. But the workflow does change from what I'll call traditional Inventor workflow to a whole different mode and method. If we I'm zooming in a little bit more so you can see that in fact it actually drilled the pilot holes for this. And if I go out to fabrication drawing, of course all of this will show up. Now let's go ahead, I'll unground the left hand side and I'll show you that it actually did drill all the holes, absolutely based on the cam connector configuration, including the clearances that were necessary at the time. Taking a look at the top horizontal piece, you'll see again the matching holes were drilled, and I didn't have to rely on adaptivity or projection, which could cause more the novice users to get into a little bit of trouble. Let's turn back the hardware and we'll recognize the fact that everything is definitely lining up the way that it should. So definitely a different workflow, hopefully an easier method to get up to speed. More considering design than anything else. So we save our drawings. Let's turn our doors back on. And I had the doors off so we could see the hardware, but let's rotate a door. And by rotating a door, you'll see that it also drilled the back of the door absolutely correctly, based on the hinging condition of the constraints that we put on to begin with. So it drilled the large pocket, and it did the pilot holes also on all four doors. So just rotating them so visually you can see that. And we'll do an update on that. So one more step. Let's go ahead and put some door locks onto at least two of these doors, a double door lock. So I'll turn off two of the doors so that we can see it a little bit better as we're attaching it. And as we did before, we're going to a library to place hardware that already exists. I can't stress enough to make sure that your libraries are up to date. that things are in place, because it's definitely going to save time. So bringing in a particular piece of hardware. This will be mortised into the top panel of the door. There's pilot holes, a whole host of things. And again, as before, we're going to attach hardware, and we can either attach it singly or we can attach it multiple locations. So it's going to ask me for the face of the door, it's going to ask me for the edge of the door, and then it's going to ask me for the top of the cabinet. It can't be simpler than that. And hit OK, and you can see that it places the hardware in automatically and accurately. So we'll turn off the visibility of the doors so you can see that there are multiple things that we're going to attach to or needs to be drilled. So as before, if we want to drill holes, all I have to do is touch what I want to drill and hit the OK button, and it'll drill those holes. So we don't have to drill the whole unit. All we have to do is drill a particular item if we so desire. Once you rotate the door, you'll also see that the pilot holes are drilled and the center pin for the actual key is drilled with it. As we get closer and we take a look at the top, you can see the top of the unit also is mortised. So you could have multiple things happening simultaneously and not at all be considered about projection of at least 3 or 4 different planes all at the same time. We'll turn the visibility of all the doors back on, and I'm going to add another lock for the right side door, and the doors can be closed when I do this. So we'll attach the hardware, touch what we're attaching, pick the face of the door, which we just did, pick the edge of the door, and pick the top of the cabinet. And there we have it. Drill that, and we're done. Save our work. Autodesk Inventor does quite a good job in terms of creating fabrication documentation from our 3D model or assembly and our parts. Creating front view, top view, side views, sections, details, creating parts lists, bills of materials, dimensioning, adding text and notes, basically creating a 2D document for printing or for presentation to clients for approvals. Many different aspects of the 3D model put into a 2D world. What I'd like to do is show you, though, some of the automated tools that are available in many of the third-party tools that are available for you, and one of them is called Autoprint. So first thing I think I'd like to do is to start a brand new drawing file, and this could be an IDW or DWG. It really doesn't make a difference, with attributes, without attributes, and we have a sheet of paper that we start. Second step is to do Autoprint, and in Autoprint we have a dialog box that allows us to view or to present shaded views, hidden line views, and so on, and which views we want and what scale we want. Once we've decided on how we want the presentation, then we can go to orientation and we can determine how things should be twisted or turned on the sheet of paper. And then, of course, what we want. What do we want to present? Maybe we don't want the hardware in the part views. So once that's done, all we do is hit the start button, and the tool will now interrogate the entire assembly and sub-assemblies and start creating separate drawing files of each of those particular items. If they have the drilled holes for the pilots, for the hardware, all of that's going to come across in the drawings themselves. And of course, they're going to be linked back to the actual assembly. So if the assembly adjusts, then of course these will adjust also. So everything we've done to this point, we're now creating drawings of. Okay, so it's finished its process. Took under 40 seconds for about 15 parts. And then what I'm going to do is go into the drawing file and just take a look and see what we have. So in the drawing file itself, you'll see that we have in sheet 1, I'll call it the master assembly. That is the parts, the full assembly showing all the parts, all the hardware, everything else. If I go to sheet 1, you can see it's the left side, sheet 2, the top, and so on and so forth. And what's going on here is on each separate sheet in this drawing file will be a separate part. The parts will be numbered or lettered based on the name. This is called door B-1, and that's a plywood top. So again, very simple, easy to do. Now let's take a look at the assembly again. And I'm going to turn off the visibility of the door and take a look at the fact that we did do some edge banding there on the top and the right hand side. So here's plywood top drawing. And I have a tool called Mark Edges. And when I pick Mark Edges and touch that top, several things is going to start to happen. It's going to interrogate the drawing and it's going to mark it in two ways. One, to show the edge banding, and two, to show the grain direction. So I can do this on individual drawing sheets, or I can do it on all drawing sheets. So if we take a look now and I zoom in, you could see that that is the code name for that piece of edge banding, and you can see there's a thickness there. And that thickness is showing you the edge banding that of course can be dimensioned. If we go up to the top right hand corner, it also creates a legend of what edge banding was used. So if edge banding is part of your day-to-day operation, then this might fit. It's also showing you grain direction all at the same time. And then of course if I want to shade it, I can shade it because it's going to utilize all the same tools that are in any drawing file in Inventor. Hidden lines, not showing hidden lines, all those things are absolutely doable. We can also do something called mark holes. Okay, it's very much like the hole command, but it is going to be slightly different in our world because it will create a whole environment on a leader that's unique to woodworking. So we have a couple other tools that are part of it. We also can scale views. Now this is a little different than scaling in normal drawing files because when you pick scale, it scales all the views at one time. Now you can only do that with projected views, but what about isometrics? This is doing all of them at once. So again, some enhancements that might be beneficial for you. You can also move all the views at one time. Now in the and keep them oriented to themselves. Normally that's something you can't do with the normal tools in Inventor. You can move one view at a time or the projected views. So edge banding can be utilized here. iLogic has been available inside of Autodesk Inventor for the last several versions and is probably one of the most effective tools in the creation of library items that can be reused over and over again. Very effective, and it acts as a configurator. So when we're building doors, drawers, carcasses, we have the ability to apply a menu system that allows for change. Again, very good for standardizing anything within the design environment. So let's get to the model and take a look at how we can apply iLogic to it. The first thing we're going to do is go into parameters. when we're in the assembly and assign 3 or 4 parameters to the assembly. Length, which again will control the model. We'll say 60 inches. We'll now apply thickness, which of course was 3/4 of an inch because I want the ability to change it at any time. Other parameters, for example, the height of the cabinet, which I believe is 40 inches. And then finally the depth, the front to back dimension of the cabinet, which is 13 inches at this moment. So what we've done, we basically have added variables to the assembly, but we've not hooked it to anything. So the next step is, let's open up the master part. We'll double click on the actual dimension that was length and type in length equals 60. So we added a variable. The next thing we'll do height equals 40. Again, this will change the parameter table. And then if we go into parameters, you'll see we have length and height. We already have thickness because we've assigned it, and we already have depth because we've assigned it. So we've done everything that we need to do. So we save the part file, the master part file, and then we do a copy and paste, and then we bring the master part file into the assembly itself. So we're pasting it in, and once it's pasted in, we'll just turn it off, turn the visibility off of that part. So we have that within this environment, and we hit save. So those are a couple of quick steps. At this point, we go to manage, we go to iLogic browser. We see we have what are called rules and forms, and the first rule we're going to set up is a rule that allows us to pass the assembly information to the parts themselves, thusly controlling the part. And this is a very, very simple, straightforward process. So we hit OK, and it opens up a dialog box that allows us to do some minimal editing. So we'll go down to the actual part file. You'll see there's a directory structure here, and we'll grab the length, right click on it, and right click on height, right click on thickness, and right click on depth, and this will capture the current state, and you can see that it's filling in the information in the lower box. So it says the parameter in the assembly equals whatever the value is at the moment. Then what we'll do is go over to the assembly parameters and say let the length value in the part file equal the length value in the assembly file. The same thing with height, the same thing with thickness, and the same thing with depth. Again, this will be in the handout, and it'll also be in the demo set for the class. The next thing is go to the forms, and you'll add a form now. These are what are in the assembly at the moment: length, thickness, height, and depth. So you capture all of them, you drag them over to the right hand side, and it automatically creates a dialog box for you. It's that simple. Just right click, move them over, it brings in a dialog box. At the bottom of the dialog box, you can actually change the way that the form will look. You can type in the name of the form, what you want to call it, and everything is done through a menu-based system. Predefined buttons, I will say I like using OK, cancel, and apply. And the visual style of the dialog box might be 3D. Okay, once this is done, I hit OK, and I have the ability now to just hit show me the dialog box, and you'll see that the cabinet upper now has 4 variables that's associated with it, which basically means when I bring up this dialog box, when I place it into a new assembly, when I do anything with it whatsoever, I can change those 4 parameters or more if I so desire. So again, very simple tool that allows me to totally configure the system. Well, I appreciate the time that you spent with me. I hope that this was informational for you. And again, thank you for attending our virtual session. Again, my name is Steve Whittam of Whittam Associates. And if you have any questions or comments or concerns, you can email me at support@whittam-asssoc.com. Thank you again for attending.